Welcome back, everybody, to another deep dive. Today, we're going to be talking about large language models and a really interesting new way to test their reasoning skills.
Yeah, one of the big challenges with the existing benchmarks is they often rely on really specialized knowledge,
Oh, yeah,
like almost PhD level stuff, which makes it kind of hard for most people to even understand what's being tested,
right.
let alone whether the LLM is actually reasoning correctly.
Yeah, like even if you understand the benchmark, are you sure that the LLM is actually like reasoning properly, or is it just
Exact.
brute forcing it?
Is it really thinking or is it just
Yeah.
pattern matching?
Right, exactly. So it's really hard to tell. And so what's really cool about this new approach is they're using something that's much more familiar. The NPR Sunday Puzzle Challenge.
Those wordplay puzzles that
Oh, yeah.
really make you think and
Yeah,
drag your brain.
those are fun. I love trying those out. This paper mentions something called like the off-air challenges, which I had no idea even existed.
Oh, yeah.
What are those?
So those are even harder than the on-air
Oh,
ones.
wow.
So they often involve like looking up words in a dictionary or using an atlas.
Oh,
So
geez.
it's fascinating because while they are quite difficult, they are solvable by a significant portion of listeners, which shows that they are based on general knowledge
Right.
and that they're verifiable.
So like you can actually check if the answers are correct.
Exactly.
That's great. Yeah, so we're talking like hundreds or thousands of people cracking these every week.
Right.
And we're using these to test AI. So I love this idea because it makes this whole thing much more accessible.
Yeah, I think
That one of
that's
the way. I'll kind of wrap our heads around it.
yeah, one of the really exciting things about this approach is
Yeah,
that it makes AI research a lot more accessible and relatable to a wider
for
audience.
sure.
You don't need a PhD in computer science to understand
Right.
what's going on and to maybe even evaluate whether the AI is really reasoning or not.
And I think that's a really good point because it helps us understand how LLMs are thinking, but in a way that we can grasp,
Exactly.
right? Like it's not
It's not just about pushing the
the
model
complexity
to
of it.
superhuman levels.
Right.
It's also about understanding how they think in ways that we can grasp and learn from.
Totally. And the findings were really interesting. One of the big ones was that OpenAI's O1 model achieved a 59% accuracy rate on these puzzles,
Wow,
which is really,
it's really impressive.
yeah, that's impressive, especially when you compare it to other reasoning models.
Yeah, it significantly outperformed the others.
Yeah, that's crazy. Okay, so that one did really well. But what about some of the other models, like DeepSeek R1, for example? How did that do on these puzzles?
So DeepSeek R1 actually struggled with the Sunday Puzzle Challenge,
Really?
which is interesting because DeepSeek R1 excels on those more complex PhD level benchmarks.
So it's almost like these LLMs are really, really good at specialized tasks. But then when you give them something that's kind of like a more general knowledge,
Right.
common sense kind of thing, they struggle a bit.
Yeah, it seems like they lack a bit of that common sense that we use to navigate everyday
For
problems.
sure, for sure. So to give everybody a sense of what these puzzles are like, one of the puzzles was you have to change the word alpha to aloha by changing the middle letter to the one preceding it in the alphabet.
That's a clever one. You
Right.
have to think about both spelling and pronunciation to get to the answer.
Totally. And it's not like you can just brute force it, right? You have to
Exactly.
actually think it through, so it's not just
Right.
a simple
It
calculation.
requires a bit more reasoning.
Yeah, for sure. What was another example?
So another example was finding a word that has the letter I in each syllable but doesn't have an I sound.
Okay.
And the answer is daiquiri.
Oh, daiquiri. That's a good one.
Yeah, so it plays in the quirks of English pronunciation,
Yeah, for sure.
which might be why some of the LLMs struggled.
Yeah, I bet. So these are tough. I like these. Did the researchers see any interesting patterns in how the different models kind of like approached or failed at these puzzles?
Yeah, one really interesting observation was what they called the giving up phenomenon.
The giving up phenomenon.
So DeepSeek R1 in some instances would literally output I give up before even attempting a solution.
Whoa, the AI just gives up.
It just throws in the towel.
That's so. I wonder if it gave like a reason why it gave up.
Well, it gets even more intriguing because sometimes after giving up,
Oh no.
the LLM would still provide an answer that it knew was wrong,
What?
almost as if it was compelled to give some answer even if it was incorrect.
That's kind of unsettling, isn't it?
It is a bit strange.
Yeah, like almost like it knows it's wrong, but it has to give something.
Right.
Huh, that's so weird. Okay, so what about the models that didn't give up? Do they all like manage to reach a conclusion?
Not always. Some of them got stuck in what researchers call thinking forever loops.
Thinking forever.
So they would hit the token limit without reaching a conclusion.
So it's like they're thinking too much.
Well, they're thinking, but they're not making
They're
progress.
just like stuck.
They're stuck in a loop.
Yeah, so they hit that token limit, and it's like your phone when you have too many apps open and it just freezes up.
Right. It just can't process anymore.
Yeah, and it can't get to that answer. That's a little concerning, especially if these LLMs are going to be used for, more important things than word puzzles. What if it's stuck thinking forever about, like, I don't know,
Right.
something really critical?
Yeah, that highlights the need for better mechanisms to prevent these endless loops
Right.
and to ensure that these reasoning processes are efficient and bounded.
Yeah, like they need to be able to wrap up their thinking.
Exactly. They need to
All right.
know when to stop.
It's like they need to know when to stop thinking and just give the answer.
It's not just about being smart.
Yeah,
It's also about being a good problem solver,
for sure.
knowing when to keep pushing and when to stop.
Totally, totally. So the researchers decided to dig even deeper into these processes, and they analyzed the reasoning outputs from models like DeepSeek R1 and Gemini Thinking. Okay, reasoning outputs. What exactly are we looking at here when we say that?
So we're essentially looking at the step-by-step thought process that the LLM goes through as it tries to solve the puzzle.
Oh, okay.
And this analysis allowed the researchers to quantify the relationship between the length of the LLM's reasoning and the accuracy of its answer.
So it's like we're trying to figure out the optimal amount of thinking that an LLM needs to do.
Yeah, the optimal reasoning budget.
Yeah, the reasoning, but
Not too much, not too little,
yeah.
but just the right amount to get the best results.
So how do we figure that out?
Well, one interesting finding was that accuracy tends to plateau after a certain point.
Really? So you're saying that more thinking doesn't necessarily equal a better answer?
Not always. It seems that there's a sweet spot, that reasoning budget where accuracy peaks.
Okay.
And beyond that point, more thinking, more tokens doesn't really lead to much improvement.
So it's almost like diminishing returns.
Exactly.
Like after a certain point, the LLM has thought about it from every angle, and any further reasoning is just kind of wasted effort.
Right. It's just spinning its wheel.
Yeah. So was this sweet spot the same for all of the LLMs, or did it kind of vary?
That's where it gets even more interesting. The plateau point varied between models.
Okay.
For example, Gemini Thinking seemed to hit its peak accuracy around 10,000 tokens.
Wow.
But for DeepSeek R1, it took longer, somewhere beyond 30,000 tokens.
So different LLMs have different thinking styles.
That's a great way to put it.
Like some are quick and decisive, and others are more methodical and take their time.
Exactly. And understanding these nuances is crucial for developing more efficient LLM systems.
Right.
Because if we know that a particular model tends to plateau after, say, 5,000 tokens,
Uh-huh.
then we can set a limit to prevent it from wasting computational resources on excessive reasoning.
Yeah. It's like you're giving them a nudge. Like, okay, you've thought about it enough.
Right.
Now it's time to commit to an answer.
Time to give an answer.
Yeah, exactly.
And this research really highlights that it's not just about making AI bigger and more powerful, it's about making it smarter about how it uses that power.
I love that quote. It's not just about brute force computation. It's about strategic and efficient use of resources.
Right.
And that comes from understanding how these models reason their strengths and their weaknesses.
Ex-
And what's so cool about using these Sunday puzzles as benchmarks is that anyone can understand them.
Right.
You don't need a PhD in computer science to appreciate the challenge or to spot when an LLM is kind of going off the rails.
And that's one of the most exciting things about this research.
I agree.
It makes AI evaluation more accessible and relatable in a wider audience.
Totally. And I think hopefully this leads to more people becoming curious about how these models work, asking questions, and maybe even contributing to their development.
Absolutely.
That would be great. I mean, AI is a really powerful tool, and the more people who understand it, the better.
Right. It's important that we continue to develop AI responsibly and ethically.
For sure.
And understanding how these models think and reason is a key part of that.
This has been such a great discussion so far. It's been really eye-opening. I mean, it's not just about AI solving puzzles. It's about us as humans trying to solve the puzzle of AI.
That's a great way to put it.
But before we kind of wrap up this first part of the deep dive, you mentioned something earlier about this reasoning budget and how it varies between models. Can you elaborate on that a little bit more?
Yeah, so what's fascinating is that the sweet spot for reasoning depth, that optimal budget, can vary significantly depending on the LLM's architecture and training data, for example. For example, models like Gemini Thinking, which are trained on massive text datasets and have billions of parameters, they tend to reach peak accuracy with longer reasoning chains. Like they have the capacity to explore a problem from multiple angles, drawing on this vast web of knowledge.
So they can really like dive deep into the problem.
Yeah, but this can also be a double-edged sword.
Oh, how so?
Because they can also get lost down those thinking forever rabbit holes that we talked about.
Right. They have all that knowledge, but they don't necessarily know
Exactly.
when to stop.
It's like having a powerful engine, but not always the best brakes.
I like that analogy.
And that's where this concept of a reasoning budget becomes so important.
Okay.
It's about finding that balance between letting the LLM explore a problem thoroughly and preventing it from getting bogged down in excessive computation.
So it's about optimizing for both accuracy and efficiency.
Precisely. Now, on the other hand, you have models like DeepSeek R1, which are designed to be more computationally efficient.
Okay.
They might not have the same raw processing power as the larger models, but they can be surprisingly effective within a tighter reasoning budget.
So it's like a smaller, more agile car that can navigate those tight corners without spinning out.
That's a great analogy.
I try.
And this is where the Sunday Puzzle Challenge really shines as a benchmark.
Okay.
It allows us to probe these different Oh, hey, welcome. What's up?
Thank you for the detailed explanation. Can we wrap up the conclusion with the key points?
I'm glad you're finding it helpful.
Yeah, I'm so glad you're enjoying the show.
That's a great way to summarize it.
It's like we're getting a glimpse into how these models tick.
Exactly.
And that is helping us better understand AI.
Indeed.
You're saying these puzzles designed for humans
Yes.
are helping us to better understand AI.
Right.
And remember, this challenge is not about the answer.
Right. But the journey,
Yeah.
it's the steps the LLM takes
The process.
by analyzing those reasoning outputs.
We can start to identify patterns and improvements.
Right. Absolutely.
One thing that struck me is the LLMs giving up,
Yeah.
as if they're experiencing cognitive fatigue.
A fascinating parallel, isn't it?
Yeah.
We all know the feeling of being stuck.
Oh, yeah, for sure.
And sometimes the best thing to do is step away.
Right. You need to clear your head.
Exactly.
What about the LLMs, though?
Still trying to equip them with metacognitive skills.
So it's not just about being smart either.
Precisely.
It needs to think about its own thinking
Exactly.
as we develop increasingly powerful LLMs.
Right.
It's about understanding how they think,
Absolutely.
about building AI that is resilient.
That's right.
You mentioned thinking forever loops earlier.
Right.
Can you explain that a bit more?
Of course,
Right.
LLMs process language in chunks called tokens.
Okay.
Each model has a limit on how many it can handle.
It's like having limited space. It
Exactly.
might hit that token limit before reaching a solution.
Running out of memory in a way, leading to those thinking forever loops.
That's concerning for real-world applications.
A crucial consideration, definitely.
So it's not just about more power.
Balance between depth and efficiency. Tackle challenges without getting lost in loops.
Teach them to be not only smart, but wise.
Cognitive wisdom in these AI systems.
This reasoning budget concept is fascinating.
Yes, it is.
It makes me wonder, are there strategies to manage them?
Yes, several promising avenues of reasoning.
For instance,
Meta-reasoning.
whoa,
Ability to think about their own thinking.
inner critic that's always looking to improve.
Absolutely.
Actually pause, reflect, and be more strategic.
Exactly.
Focus on efficient reasoning algorithms.
Remember the thinking styles we talked about?
Uh-huh.
Some algorithms are naturally more efficient.
Right. Tool for the right job.
You got it.
Algorithms are suited for some problems.
Exactly.
A way to navigate twists and turns effectively.
A proving ground for reasoning algorithms.
It's amazing these puzzles advance the field of AI.
Right.
You know, we learned so much from studying AI.
It's a powerful reminder. It's about creativity and problem solving.
Exactly.
Common sense.
The blend of wordplay, logic, and thinking.
Testament to those puzzle creators.
Ingenuity.
Strengths and weaknesses of LLMs.
But also nuances of our own minds.
Yep.
New perspective on responsible development.
I'm so glad you found it thought-provoking.
Before we wrap up with a final thought,
Yes.
to improve our own cognitive abilities.
It will occupy researchers for years to come.
On that note, it's time for us to sign off.
Remember to keep questioning and learning.
Keep diving deep.
Bye-bye.
Goodbye.